Every click on a modern digital storefront feeds into a living, calculating machine that reacts to your presence in real time. To understand the scale of this math, consider that 35% of Amazon's massive revenue is generated entirely by algorithmically recommended items, rather than organic user searches. To see how these digital storefronts operate, we need to separate artificial intelligence from machine learning. While artificial intelligence is the broad concept of a machine mimicking human intelligence, machine learning is the actual engine inside it. It allows a computer to learn from data and improve without being explicitly programmed to do so. Machine learning generally comes in three flavors. The first is supervised learning. This is where an algorithm is trained on thousands of neatly labeled examples of historical data to accurately predict future outcomes. Next is unsupervised learning. Here, the algorithm scans massive amounts of completely unlabeled data to find hidden patterns and naturally group similar things together. Finally, there is reinforcement learning. In this approach, the algorithm learns through trial and error, constantly adjusting its actions to maximize a specific programmed reward. These three concepts are the invisible clerks dictating every click, scroll, and purchase on your screen. The moment you type trendy summer shirts into a search bar or a customer service chat, you initiate the first step of this calculation. But how does a computer actually understand that specific phrase? It uses natural language processing, or NLP, which is a branch of computer science that helps machines understand and interpret human language. Specifically, many modern search bars use a technique called Word2Vec. Word2Vec turns words into mathematical vectors, numerical values that plot a word's meaning on a spatial grid. It groups similar words based on context. Words we know to be synonyms tend to have similar vectors and cluster tightly together. This relies heavily on supervised learning. The system is trained on vast amounts of labeled human language text, allowing it to predict precisely what concept you are asking for, even if you misspell a word or use unconventional phrasing. The machine calculates the mathematical proximity of your intent to the inventory sitting in its warehouse. Once you reach the storefront homepage, the site often seems to know what you want to buy before you even type a search. This is driven by Amazon's specialty, item-to-item collaborative filtering. This is a filtering system that predicts a user's preferences by looking at items they have previously purchased or rated and pairing them with similar items. This mechanism leans heavily on unsupervised learning. The algorithm takes millions of unlabeled data points and groups your profile with thousands of strangers who share your exact browsing history. This image shows the real-world interface of this mathematical clustering. The customers who bought this item also bought section pairs distinct items together based entirely on hidden behavioral patterns found in the data. This creates the personalization paradox. Consumers demand hyper-curated shopping experiences that save them time, but they often feel deeply unsettled when the algorithm acts like a surveillance tool tracking their every move. The algorithm focuses on finding users who behave exactly like you and simply predicting your next inevitable purchase. When you finally reach the checkout page, you might notice the price of plane tickets or over-the-counter allergy medicine fluctuating dramatically from hour to hour. These are dynamic pricing algorithms at work. They operate on reinforcement learning, where the bots are unleashed into the market with a single goal: maximize their reward, which in this case is corporate profit. This Harvard Business School working paper details how dynamic pricing algorithms monitor competitors and adjust prices in real time. The researchers document that even without illegal collusion, independent algorithms learn that keeping prices uniformly high maximizes their reward, extracting wealth from consumers. This automated ecosystem is optimized to extract the maximum amount of wealth from the buyer, regardless of how competitive the market appears to be. This automated architecture is now available to small-scale sellers, democratizing this pricing power through third-party vendors. This academic paper shows how small and medium-sized enterprises in emerging markets are aggressively navigating this AI-driven transition. They are utilizing these automated tools to optimize their operations and overhaul their customer experience. Because these invisible mathematical tools hold mass power over consumer choice and daily pricing, global governments are stepping in to regulate the black box. Under the impending 2026 EU AI Act, e-commerce shops will face strict new legal mandates. They must clearly disclose their use of AI chatbots, and their dynamic pricing models will face intense scrutiny for high-risk profiling that affects consumer access or pricing. Every interaction behind the screen is a data point in a continuous, live machine learning experiment. Remember the architecture operating underneath the next time a price jumps or a recommendation appears.